Welcome to the first tutorial for Computer Science 1A. Today we'll be going through Practical 1. We'll be going through the memo for Practical 1. So let's see. There's a lot of explaining that I have to do here before we start coding or programming. So there's terms like coding, programming, all those terms that are used interchangeably. I need to explain and provide a bit of clarity on what those terms mean. So let's start with let's start with what's programming, right? So programming, if you look at the word programming, right, it's derived from the word program, right? So before we can understand what programming is, we need to understand what the term program means. So the term program, right? And program is just I would say let's just say it's just an application, right? That consists of a set of instructions that is an application that consists of a set of instructions that perform a specific task. So a program is just anything that performs a specific task, right? For example, a program like Instagram or WhatsApp or Twitter, those are all programs, right? Because they consist of a set of instructions that perform a specific task. So the task could be if an application that allows you to upload pictures, right? So that's a task. That's a specific task. I'm uploading pictures. It could be uploading pictures on Google Drive or T Drive or what is Google Drive or OneDrive. So it could be an application that does that. So that's what we call a program, right? And then the art or the process of programming. What is programming, right? Programming is just the process of planning, designing. So planning and designing can just say it's the same thing, right? So it's the process of planning, designing, um, and making or implementing. I'm just going to use very simple English and making a program, right? So it's the process of planning and designing and making a program. So it comprises of all these steps. You plan, you design, and you make the program. And what did you say a program is? It's just any application that consists of a set of instructions that perform a specific task, right? So the set of instructions, right? What's the set of instructions? It's just lines of code, right? Of which we're gonna learn how to write those lines of code or those set of instructions. And programs come in different ways, like different operating systems, right? Have different operating systems different operating systems have different ways of identifying what a program is. Yeah, I would say extensions. They have different extensions that denote what a program is. So if you look at Windows, right, the one we're most familiar with, it's any program or any application. I'm just gonna use the word program because we are programming. So any program on a Windows operating system, it's denoted by a .exe extension, right? I can show you this by opening Task Manager, right? If I open Task Manager, it shows me the tasks that are being executed on my operating system, right? If I make this a bit wider, okay, why is not showing now? Let's see. Okay, it's not showing, so let me do this. So yeah, let me quickly do this. So let me go to my deleted applications and then let me just restore this. Just gonna restore just one application, right? So if you look at this application, right? I hope you can see my screen. So if you look at this application, right? If you look at this application, it ends in a what? .exe. The .exe on the Windows operating system, the .exe is just they just derived the word from the word executable. It's an executable file or it's a program, right? So that's how you find out which programs which are the programs on the operating system, especially on Windows. That's how you find out. You're like, oh, okay, it ends in a .exe. That means it's a program, right? That means it was written by people and it consists of a set of instructions. A set of instructions can be anything, right? The most simplest example or the most common example that I can use, which is like it's common, it's something that we all familiar with, like a recipe, right? A recipe just states how it has a set of instructions on how to cook, right? That's a recipe on how to cook or how to make specific a specific a specific meal, right? Which is almost the same as this program that we're trying to implement. Look at the program. It says it's an application that consists of a set of instructions. I wouldn't say, okay, let's just say, okay, let's remove this. Let me remove the first part because if I use application, I feel like now yeah, let's just keep it this way. A program is just a set of instructions that perform a specific task. That's a program, right? So we can liken a program to a recipe, right? A recipe, it consists of a set of instructions on how to make a specific meal, right? So let's say, for example, you want to boil an egg. How to boil an egg recipe, right? How would it denote, or how would you write the steps for how to make an egg? So first step is get the egg. Get the egg or eggs. Could be egg or eggs. Get the egg or eggs, and then let's just say from the fridge, something like that, right? Or if the eggs are not there, or just buy the eggs if you do not have the eggs. And then step two is um, put a pot with water on the stove. And then step three, put, or you can say add or put, doesn't matter. So put the eggs inside the pot. And then step four could be something like after 5 to 10 minutes, take out the eggs. Something like that, right? And then step five, after you've taken out the eggs, obviously you need to peel the eggs. So, and when you boil an egg, you're most likely gonna take the egg and put it in a bowl of cold water so that it's easier to peel. So you can just say put the eggs inside a bowl of cold water, something like that, right? And then it's not the last step, just say peel the eggs. That's one of the steps. And then last, step seven, just enjoy your meal. You can say enjoy your meal, just eat the egg. And I don't need to tell you to put salt on the egg. You know that you need to put salt on the egg, but you could also add it as an instruction there. Because some people will take your instructions literally. So you should say, after peeling the eggs, um, add a pinch of salt on your eggs. So you just add a pinch of salt on your eggs and then enjoy your eggs. Let's just say not meal, because some people might take it literally and be like, okay, what meal are you talking about? But the person can clearly see that it says how to boil an egg recipe. So these are the steps, right? So we follow the same procedure when it comes to programming. And in order for you to become good at cooking, right, you'd have to understand things like spices, how to blend spices well, the tools. You also need to know how to use the tools. What is the pot? The difference between the stainless steel pot and the steel pot, all those things. You need to have a non-stick frying pan, all those things, those tools, the spoon, the fork, the knives. You need to understand and learn all the tools, right? You don't just expect a programmer or you don't just expect someone to become a chef. In order for someone to become good, to become the best chef or a chef in general, you don't expect the person to just watch you cook and then imitate what you did, and then you just give him the tools and say, start cooking. You can't do that. You have to teach him the tools that are required to become the chef or the tools required to make the meals, right? So it's the same approach that we're going to take in this in this program, right? In computer science in general, that's the approach we take. You you learn the tools first, and then you learn the tools and how to use the tools. After learning the tools and how to use the tools, you get a problem where you need to apply and use the tools. So, for example, you you learn the tools and do everything, and then you go you have to make a meal for people who are pros, right? So, for example, you have to make a meal for Gordon Ramsay. You have to make a meal for him. So you can do things like that. But in order for you to get to that level to be able to make meals for other people, other chefs, you need to be taught about the tools. You need to talk about the meals, how to make the meals. May, maybe an example. They show you an example how to cook chicken, something like that. So it's the same thing here. I'm going to show you, teach you step by step on what are the tools required, everything involved in making the program, right? Remember, our goal is to make the program. We want to be computer scientists, right? Or programmers. So the term used for people who make these programs, right? The people who make programs. The people who make the programs are called programmers, right? Just like people who make food are called chefs. It's something that they need to have a name. So at the end of the day, we want to become the best programmers and make websites and make applications and things like that, and be part of the companies that make self-driving cars and all of that. So in order for us to get to that level, we need to take it step by step, baby steps, one step at a time. Understand this, how to formulate a recipe on making the program and the tools that are required. So you need to remember, in order for you to make the egg, you need to know what a fridge is, right? And you need to know where to buy or what does it mean to buy. So there's a lot of things that are involved here. You need to know what a pot is. You need to know what minutes are, how to measure minutes, all those things. You need to know what a bowel is, what is water, what is cold water, the difference between warm, hot, and cold water. You need to know all of those things, right? So we're gonna take the same approach. So now I'm sure you're probably asking yourself, okay, what's the point? Why C++? Why all of those things? Like, couldn't we if so with the programs that we're going to be writing, right? We need a language we need a language for us to be able to write the instructions in. So the language that we're going to use in this class is C++, right? Why C++? So let me take you down. Let me take you back. Let's have a history lesson and look at okay, let me create this. So let's look at a bit of let's take a trip a trip back in history. So let's look at why C++, right? I mean, couldn't we have used other languages or something like that? So let's look at how it works. So the way it works, right? Remember when you have people like this, right? I'm gonna put the last person at the end. So remember this is come on. No, just give me a sec. Okay. So remember this is you, right? You speak your native language, right? You have your native language. Let's say your native language is French, something like that, right? And then on this side, come on, why isn't it allowing me? You know what? This thing is really annoying. Let me see. Can't I edit the text somewhere here? It was not allowing me to select the text. So this is there's another person here. Another person who speaks let's just say this person speaks English, right? So the issue here with, let's say you're trying to have a conversation with this person, right? The issue or the problem that's going to arise is that this person only, let's say this person only speaks English and you only speak French. How are you guys going to communicate with each other? It becomes a problem. So that's why there's systems or things that we developed in order to avoid this language barrier, which is a translator, right? So you're gonna need a translator. So this is where a middleman comes in place. So we're gonna have a middleman here. So this middleman is gonna be the translator, right? So this middleman is gonna be the translator. When you instruct this person and tell him, okay, tell him something in French, he's gonna translate that information and send it to this person in their native language, which is English. The same goes when this person says something back or a response to he talks and communicates with the translator, and then the translator sends back that information to the person in their own language. So there's that middleman who's doing the translation and everything. So now you might ask yourself, okay, why didn't we just use the most dominantly used language in the world, which is English? Why didn't we just use that to write our programs? I mean, if you look at the recipes that we write for people, it's written in a language that's easier to understand, right? So if you look at this language, it's English, and it's most common. It's the most commonly used language in the world, so it makes things simple. You can also easily translate it to your own native language, right? By using Google Translate. So now we're gonna go into why couldn't we just use English? The problem with English is that it is a lot of ambiguity, right? There's a lot of ambiguity, right? So there's a lot of ambiguity, meaning that the language itself there's one word can have multiple meanings, right? So I can have, for example, the term integral. Integral meaning a number. Or I can use the word integral meaning something, it is of some importance, right? So you see, one word can have multiple meanings. The same applies to kill, something like that, to unalive person, right? That's the definition I think the dictionary uses. I'm not sure, but yeah. And then kill, let's say you use kill in a sentence, right? And you say your jokes are killing me, right? This kill in this sentence, it means a different thing. It's figurative. It doesn't mean it is not, it doesn't have a literal meaning. So you see, that's the problem with English. It's a bit ambiguous. There's one word can have multiple meanings, and that becomes a problem because if I tell the computer to say, let's say I've made an artificial intelligent being, which is like a robot, something like that. I've built a robot, right? And it's communicating with the person, and I tell the robot, okay, um, react to whatever the person say or do, or you tell it to say your jokes are killing me. It might misinterpret the statement and just unalive the person. So that's the dangers with having a language that's very ambiguous. It leads to a lot of there's a lot of unpredictability in your programs, and we don't want that. So what happens is what usually happens, right? There's two people involved, right? There's the there's the there's the code, right? The machine. Remember that the same way we have our own native languages, right? The computer has its own language, and we can call that machine code. But not code as such. Let's just say machine language, right? Machine language, right? So the machine language, right? Usually, in simple terms, I'm going to explain it in the most simplistic terms. The machine language, right? Machine language comprises of zeros and ones, which basically literally means 0 and 1. That's how the computer, that's the language that the computer speaks, right? So one meaning that there is little currency, something like that, and then zero meaning there is no current, not currency. There's no current, right? So one meaning that there's a presence of electricity, zero meaning that there's no presence of electricity, right? So in the most basic manner, that's the language that the computer speaks. So you might ask yourself, okay, why didn't we just write the programs in the language itself to make things simpler? Well, if you write in the language, remember this is the only way it speaks, right? So let's say I want to calculate the sum, right? I want to add, right? Let's say if you want to add, right? Let's say that will be represented with something like that, right? And then subtract, or that will be represented with something like that, right? And then to load, meaning to take information and put it into main memory. So we'll get I'll have a separate lesson on that where I go in depth into what it really means, the whole computer, everything, how it works. So loading just means it's loading from you can just say from secondary storage to main memory, right? So let's say to load, right? It's like 1 1, something like that, right? And then And then, yeah, so something like this, right? So let's say I wanted to write a program that is these two things, right? It just says 1 plus 2. So the instruction that I would have to write, I would say in code, in machine code, right? So machine code meaning that I'm writing the lines of code or the statements in a language that the machine speaks, which is the machine language. So we just call it machine code. So the first thing that I would do, I'll say load the value 1, right? So let's say load 1, right? And then after loading 1, and then I would say add meaning this is the number in machine code, add 2 to that number. And then let's say maybe to print something, it will be something like that, right? And then I would say print the result, right? So print answer. So I'll just copy this and paste it there. So what this means, it means load into main memory, something like that, into, let's just say, let's not use terms that we haven't discussed yet. So I'm just gonna say, you just imagine, so this means x, say x is goes to 1, right? And then this line just means y is equals to x, and then to that current x variable, add 2 to it, right? Which is just gonna be 1 plus 2 at the end of the day, right? So now I need to display the answer, which is just 3. Remember, this will be equal to 3. So something like that, right? So I'm just gonna remove this comment and then go back to what I was explaining. So as you can see, this is a very simple program, right? You're just adding 1 and 2 together. So what programmers end up realizing was that it's too complicated and that it's error prone to write in the language of in the machine language, in the language of the computer. So what they developed were things called mnemonics, right? Basically phrases like add, meaning to add, and then sub is just an abbreviation of subtract, and then mul, just an abbreviation of multiplying, and then what's the other one? Div, just an abbreviation for divide, comes from the word divide. So they just use divide. So in places of this, you'd have to use a string, right? So you'd have maybe a keyword like load, right? So this code over here, right, can be rewritten like this. I can say load 1, and then after loading 1, add 2 to that value, and then print the answer, right? So they develop programs like this, and as you can see, it makes it easier to sort of like understand the code, right? You can see that's a number. You speak English, right? So you're taught in English, so and majority of the books are written in English. So you know what load means. It's easier to look at to understand it. You know what add means, what print means. It's easier than numbers, working with numbers. Even if you're a maths genius, right? This is very complicated. You can make a mistake, for example, forgetting the 1 there at the end, and you're not gonna find out where the error is exactly. So this became a better convention or better way of doing it. So you just load 1, add 2 to that 1, and then print the result. So this made it way simpler, right? But then they also realized that this was far too complicated, because in order for you to write these commands, right, these lines, you need to understand the operating system. So you'd have to go and learn Windows operating system first, the hardware. Like you need to learn the hardware, the physical parts or the physical components of the computer, which is your RAM, your CPU, your your disk, all of those things that are inside the computer. You have to go and learn them and understand exactly how they work, because this is what we call low level. it's low level because you still need to understand the hardware itself, right? That's why we're calling it low level, because you need to go to the lowest level ever in order before you can write a program. And then languages like C, C++, Java, Python evolved, right? These languages, you didn't need to know anything about the operating system itself. And they made it way easier to program because it took some of the concept we have in our languages like English, French, all of those languages, the similar things that are there, and it became way easier to code or to write programs. So now in C++, to write a program that adds the two values, right? I'll just do this. I'll say, okay, let me not include unnecessary things. I'll just say x is equals to 1, right? And then I do that, and then I say y is equals to 2, something like that, right? And then I say z is equals to x plus y. And then I'll just see out to print the result. So print the result that's stored inside A, right? So inside Z, I mean, sorry for that. So you print the result that's stored inside Z, which is the result of adding whatever's inside the x variable and the y variable, right? So what would happen in this line, right? It's literally going to do this. It's going to say Z is equals to what's stored inside X. 1. X is a placeholder for 1. And then what's Y? Y is a placeholder for 2. So 2, which gives you 3. So now Z has the answer of adding the two values. And then you just output the value. So that's sort of like the short history of programming and how it evolved. So we are currently here, right? It's You might think it's way complicated, but it's way easier than having to do all of these things above. Imagine before you write a program that adds 1 and 2, you need to go and learn the hardware of a computer. You need to know what RAM does and what secondary storage does. You need to understand registers, you need to understand CPU, all of those things. So it made programming very tedious. So now we are here, we don't need to know about the operating system. We let C++ or Java, whatever language we are writing the programs in, to handle all those minute or small details. So that's a bit of history on this thing. But we remember the computer, that this is not the language of the computer. We are writing it in our own language, right? So what happened is that since you can't write it in this language, in the machine language, and we also can't write it in English, the developers made an agreement. They're like, okay, let's make a language that's like an in-between. So it takes some parts of the machine language or some parts of machine code, and it takes some parts of English, right? So as you can see, ENDL, if you write it in full, this is end line, which is English, right? So if you look at C out, you can just write it in full as console out, console out put, right? And you can write it in full like that. So you see that it's similar. They took some similar traits between the two. So they made a trade-off. They're like, okay, since we both agree that writing it in your language, writing zeros and ones is complicated. I'm not a mathematician. I'm very bad with numbers. So most people are. So we're not gonna choose your language. And then we also looked at our own language. We're like, nah, English is very complicated because there's things like synonyms, antonyms, what, and it became very complicated. So we're like, okay, we can't use English, we can't use your language. Let's build a language that's like a trade-off. It takes some parts of your language and it takes some parts of our language, and then we use that. But then, even though we took some parts of machine language and some parts of English, this still needs to go through a process of translation. Because if you look at it right now, this is exactly what we have. we have C++ here, right? And then we have machine language, C++, machine language. The computer doesn't speak in C++. It's not our language. It's not its language. It's a made-up language. We invented the language as peoples to make things easier for programmers to start coding, right? Because we saw that we can't be writing mnemonics and having to study the operating system before you start coding. It's very complicated. So this is what's happening here. The C++, which is still in another language, but it's far better because it removed the ambiguity that English has. This thing of one word having multiple meanings. C++, one word has one meaning. That's it. There's no way the computer can misinterpret or not understand what you're saying. It's forced to understand what you're saying. So there's C++ here, there's machine language. We need to have a translator in between because this is C++ and then this is the middle. We need to have a translator. So the translator is called a compiler, right? That's the translator. It has a name. We call that the compiler, right? So whenever you hear your lecturers saying, uh, compile, did you compile it? Did you install this compiler, set up this compiler? That's all they're talking about. It's a translator. So when you write this is you, right? You know C++, right? That's your language that you speak. So you can, after this class, after both semesters, right? You can write on your resume that, yeah, I speak C++ now. That's one of the languages that I speak. It's sort of like some joke, whatever, but you can write it there in your CV. So you know by the end of this course, you're gonna know C++. So this is you right here. You write your C++, you send it to someone who's going to translate, and then it translates it to the language that the computer speaks. And during the translation, there's no confusion. It's not going to be like, what do you mean by killing? What do you mean by this? What do you mean by integral? Do you mean the integral for a number or the integral meaning that something is of some importance? What do you mean? It's not going to face any of those issues. It's going to know, oh, you mean this? Okay, let me translate to the computer. Oh, you mean this? Let me translate to the computer's language. So this is what's going to happen behind the scene. So the translator or the compiler is going to be doing the translation from our code that we write, C++ to machine language. And the machine language is going to be something like this. And after it's compiled and everything is compiled, it's going to store it. Remember when you talked at the beginning, when I talked about the .exe file. So the .exe file is the file that is the translated version of our C++ or Java or Python programs, right? This version is the version with the machine language, the language that the computer speaks. So with the Visual Studio, right, code.exe, you saw that this is also an executable. That means it has the language of the computer. So if I right click and I say edit with Notepad++, you should see a very peculiar and very interesting syntax. You see, if you didn't have C++, you'd have to write it in this language. Look at it. Look at how untidy and confusing this thing is. Look, you need to write it word for word. Remember when you start in Notepad++, it's empty like this. You'd have to write every character like this. And some of these characters are pretty impossible to, yeah, they're pretty impossible to write. Your keyboard character set or the letters on your keyboard, they're not sufficient enough to accommodate all of these characters, which also becomes a problem. So you see, this wouldn't work. Look, this is how you'd have to write just a simple hello world. You have to, we'll check the hello world program in C++. Oh, no, we'll see the translated version in C++ and see how it looks. You see, it's very cumbersome. It's very untidy. It's just all over the place. So that's why we prefer the programmers made a language that's easier to understand. So that's enough of that. So let's start coding, right? I've talked a lot on the history of programming, so let's get to the actual programming part. So the purpose of this assignment is for you to get comfortable with basic data types and C++ expressions, right? So this practical wanted you to get familiar with basic data types and C++ expressions, right? So the following displays the revenues in millions of rands, right, made by a car dealership in 1 year. So rands can be converted into dollars by multiplying rands with the following conversion factor. So to convert to dollars, right? You're gonna multiply these rands, right, by that factor or by that value. So each month's revenue must be stored in integer variables, right? Each month, okay. So even though they said it's in millions, right? It's in millions of rands. You don't have to put the millions. Don't write it in full. Don't say 52 million. Just write 52. So that's why they chose integer data types here. But you could write it in full and no, let me see. Yeah, you can. Yeah, you can. Yeah, you can. Yeah. Let's not just write, let's not write 83. Let's write it in full. 83 million, 29 million, all those values. Let's write them in full. So let's open code blocks and start coding, right? And start writing the program. I'll explain some of the things as I go along. As we go along and write the program, I'll explain some of the things. Because one thing I've noticed, if I make just a video explaining that concept and there's no practical, students don't watch the recordings. So yeah, thanks to your approach, now you guys are gonna have to learn it this way. I'm gonna have to do the practical and explain it through the practical. So let's write a C++ program and okay, associate. Yes, so let's create a new project. To create a new project, there's options here. You just click on create a new project and we're doing a console application. So there's a term that I want you to understand very well. So when you click your Windows icon on your keyboard, the Windows icon on your keyboard, and you type CMD, you're gonna see something called command prompt. And then you press enter. And you're gonna see this black thing here. This is what you call the console or the terminal. There's two, or the command prompt. Three terms for it. Command prompt, terminal, console. This is what it. So we're building an application, a console application that runs on the console. It runs on this thing. That's why when you click run and you execute the application, it should open this black terminal. So I'm gonna click console application. Don't focus too much on other applications. These other applications are very complicated. The most simplistic application you can build right now is a console application. So that once you're comfortable, you can play around with other ones and go to YouTube, download books, then build other applications. But for now, this is what we're building, a console application. We are not learning C, we're learning C++, and C is a precursor to C++. So C++ is like an extension, not like it is an extension of the C language. So that's why you see these two things here. That's why you see C here, no pun intended. So that's why you see C and C++ here, and C++ it has the C in there. It means it took C++ and plus plus, meaning that it added a few features. So it extended the C language. So you press next and then you build your project, right? I've already created a folder to save my C++ projects. You could create it and then allocate and then go to that folder. I don't want to go into too much details, unnecessary details, because now the video is going to be very long if I go into unnecessary details. So what's the project title, right? What's the name of the project? So I'm going to call it practical Okay, let me just say practical one, right? This. So practical one, and then next, and then don't change anything here, don't touch anything, just click finish. And then you should see on the left panel here, you're gonna see the name of your project, practical 01. Click under sources, double click under sources, and then you should see a file named main.cpp. And then you double click, and then there's your code, right? And then I'll just zoom in here. Let me see. Let's see. Toolbars. I want to view Shift F and okay, full screen. So this is what I wanted. I wanted it to be full screen. And then view. Okay. So there's the application, right? Okay. I think full screen is not gonna be convenient in this way because now I have to shift back and forth here. So there's the application, right? You're seeing a lot of things here. So let's explain line by line, right? So we have this line, which is a preprocessor directive, right? This is what we call a preprocessor directive, right? So all preprocessor directives, they start with the hash, right? With the hash at the beginning there, and then there's different types of preprocessor directives. The one that we're going to be working with in this application is the hash include. Hash include just means include or put that file, make it available because I'm going to use some things inside that file. What file are we including? Is the IO stream. IO stream. Okay, I think my code is gonna be filled with a lot of comments. So IO stream, right? Okay, before I explain okay, there's a lot to explain here in one video. There's a lot to explain. So we have this thing called comments, right? Let me show you, let me explain comments. Comments, there's two types of comments. There's this one with two forward slashes, and then you write something here. A comment is a comment, right? It's useful when you have to explain your code, right? When there's some part of your code that's very complicated, so you write a comment to explain exactly what it does. So there's two types of comment. This is what we call a single line comment, right? Because it only spans a single line. You could, if you start writing in the next line like this, it's no longer a comment. As you can see, it's highlighted differently. So this is just a single line, meaning that you can only write it within that line. Then if you want it to span over multiple lines, there's the multi-line comment. This is a multi-line and can span many lines, multi-line comment. It can go or span multiple lines, right? So there's these two types of comments, right? So comment is just to say to just add it's like when you read a textbook, right? There's that note that adds extra information, right, on your to explain what that thing means. It's just an extra explanation, right? So it's the same thing. That comment just means, okay, I'm just adding a bit of information just in case you don't understand what this line of code does, right? Line of code is it just mean that those characters or that string written in that specific programming language, right? Programming language basically means a language that we use to program, right? Or for programming. It's the language that we're using for programming. That's what we call a programming language. The programming language that we are using is C++, right? So I'm teaching you the syntax for C++, just like in English, right? From primary, you are taught, oh, you're taught vowels. You were taught vowels A, E, O, U. You were taught all those things, right? You were taught full stop, question mark, comma, sentences, paragraphs, essays, letters, all those things, right? So that you understand the language. So it's the same thing here. That's what I'm trying to explain, so that you also understand the C++ language. And be sure to take into account that each C++ statement, okay, we'll get to that, but yeah, we'll get to the statements part. So each line of code, or each line, right? Like for example, this line, see out, hello world, we call that a statement. Or in English, you call this a sentence, but in programming, we call it a statement, right? That's a statement. It's a statement. So this is how you would write comments, right? So I'm just going to be writing a lot of comments in here. So let me write a multi-line comment. So this is a multi-line comment, right? So a multi-line comment, I'm going to explain what's going on here. This is a preprocessor directive, right? Um, it always it always begins with a pound or hash, which is this character here. And when you see this, when you see these characters here, it means it belongs. Let's just say it's not okay. I'm gonna say it again, right? What I'm about to say, it's not really accurate, but for the purposes of you understanding, I'm gonna put it in that way. I'm just gonna say if you see a less than symbol and a great followed by a greater than symbol, and then within the two symbols is a string of characters or a string, it means that whatever that file I'm looking for, it belongs to C++. It's part of C++. I didn't create that file. So that's what it means. And then when you see something like this, say for example, hash include, and you see things like this, it means I invented it, right? It means that it is part, basically it means look for it inside my project folder because I invented it. That's what it means. So hash include, it means include that file. Basically it means copy and paste. So if I go to this file, right, and I open the iostream file that I'm including, this is what I'm including. I'm including the cin, cout, cr, clog, buffered and buffered. Don't have to know about this. I'm just showing you the file that I'm including. And as you can see, it says ISO what? It's part of C++. So that's why I put those greater than and less than symbols to denote and tell the compiler when it's busy translating, or the preprocessor, not the compiler, the preprocessor. Remember, it's a preprocessor directive, right? Meaning that it's handled by something called a preprocessor, right? So preprocessor, look at the word pre means before. So before what? Processing. Before you start processing the code, go do this thing, handle this thing. That's what the preprocessor does. It goes and handles the things that you're telling it to go and handle. In this part, I'm giving it the instruction, go find that file for me. It's like your granny is telling you, okay, listen here, take this money, go buy bread at the spaza shop. So that's what you in that scenario, you would be the preprocessor because you are the one who's handling that thing. You are the one who's going to buy the bread. But the preprocessor directive is the process that your granny told you go buy bread. That's what we call the preprocessor directive. In this case, what is the directive? It means include, or in a way, go get. That's what it means. Go get, right? Include means just go get that file. So that's what that first line means. And then when you come to this line of code, using namespace standard, don't worry, I'll upload my code and then on OneDrive and then send you a link, or Google Drive. I think it's OneDrive or Google Drive. I'm not sure. So what does the using namespace standard mean? Using namespace standard, I use it so that I avoid having to reference the. Remember when I say hash include iostream, I'm telling it to go in and include that file, right? Go and get in that file and then paste it there. So that's what it means, the hash include. It's just gonna copy and paste whatever text. So this is what it does. It's gonna go here and then select everything, copy, and then it's gonna come here and then it's gonna paste it there. So it's gonna make it available. So now I can be able to use C out, C in, all of those things. But this is the most simplistic way of writing it because I didn't write that code, so I can't just be copying and pasting, because what if they update the code? If I copied and pasted, then I have an old version of the code. But if I just say include iostream, when C++ developers or the NCISO community fixes and adds updates to C++, I don't have to worry about that because I said include iostream. It's going to include the latest updates. So that's what it means to hash include. That's what that preprocessor directive means. And then we have using namespace. So using namespace, you're avoiding to reference the tool, um, um, reference to reference where you are getting the tool from. So if remember a namespace is a feature that was developed by C++ programmers so that when you create things, when you create identifiers, right, or functions or anything of that nature that have the same name, they don't have to, it's gonna avoid conflicts, naming conflicts. So this it also has the benefit to it helps to avoid naming conflicts, right? So let's say you declare something like, let's say in your code you want to declare something named C out or C in, right? So with namespace standard or a namespace, it makes it easier for you to also create your own version of this, and then it can tell the difference between, oh, this belongs from C++, and this is your own creation. That's what the namespace standard is for. So when you say using namespace standard, you also avoid it helps avoid naming conflicts. So you can declare things that are already named. It helps to avoid all of those things. So it also helps to remember what this first line that I said here. I avoid having to reference where you are getting the tools from, right? So that means I avoid typing standard scope resolution. So this is what I'm avoiding of typing in my code. If I don't include this line, I'm gonna have to type this every time. A namespace, the way I view it, right? The most simplistic example of a namespace. Imagine you have a set of pens, right? So let me do this. Pens. So let's say you have a set of pens, right? And these pens, right? Let's look at these pens. Come on. Okay, let me go to images. Yeah, let's say this exact image that I'm look. Uh, come on, open. Okay, so let's say you have these pens, right? You and your friend bought these pens. You see these pens, they're exactly the same. So to avoid having to use another person's pen, to use a pen that's not yours, we have things like what? Pencil cases, right? So after you're done using your pen, you put it inside a pencil case. So the same in this scenario, right? C in and C out would be the pens. And then the pencil case would be namespace standard, would be the namespace itself. So, excuse me. So a namespace, what it does is it behaves like a pencil so that you don't use other people's tools or other people's pens. And even if you have the same pen, the fact that you can have the same pen, but let's avoid scenarios of you having to buy the same pencil case. That's a rare. We have different taste, but pens, pens. Maybe your parents buy you pens, right? Let's say your parents, you and your friends' parents are friends, right? They're acquaintances or friends or whatever of that nature. They will go and buy the same tools for you guys, right? They might buy the same pens. And then they say, okay, for pencil case, you will choose whatever pencil case you want to choose. Then obviously you have different taste. You'll choose a pencil case, maybe that's pink. Your friend's gonna choose a pencil case, maybe that's purple. And then you have these two different pencil cases, right? So those pencil cases, they behave like namespaces. You can have the same pens, but the fact that they're in different pencil cases, each person knows, oh, this is my pen because it's in my pencil case. And then that's your pen because it's in your pencil case, of which the pencil cases are different. So that's the example that I'm going to use to explain namespace. So a namespace, just view it as a pencil case. Namespace, view it as a pencil case. It's just something that you put in your tools in. It's like for for people who have used tools before. They who have used tools before. You know that this thing called a toolbox, right? So a namespace is somewhat like a toolbox. It's a tool, it's a thing that you put in a set of tools that you're gonna use, right? And we need that namespace or we need that toolbox because what tools are we using? We are using cout and line. So we need those tools. And they belong to that toolbox, which is the namespace called standard. And I also avoid having to specify what toolbox it is. Remember this line, what it does. It means go to this toolbox and then take these two colons, right? It means go into this toolbox and take something called cout or a tool called cout. It could be for people who know toolboxes out there. You could be, let's say that toolbox is it's a red toolbox, right? And you're saying scope resolution. You're saying take pliers from the toolbox, right? That's what it's similar to that scenario. It's just a toolbox where you go and where you store your tools, and you can imagine that toolbox as a color or a name, right? And in this case, our toolbox is called the toolbox that we're gonna use is called standard or STD. So we have that out of the way. I don't want to make the video too long. Now it's already 1 hour. So let's create variables, right? So before we create variables, let me explain variables. Um, variables is, if you remember in your math class, you did variables. You know what variables are. But I'm going to show you how it works in a computer. In a computer, when you create a variable, right, there's three things you need to provide. To create a variable, there's three things you need to provide. You need to provide the name of the variable, the data type. Okay, let me write it in the order. The data type, the name, and the value. What is that? What are you going to store? Data type it just means what type of data are you going to store? Are you going to store floating point numbers? Are you going to store integers? Are you going to store remember floating point numbers is just, if you remember your math class, floating point numbers is just rational and irrational numbers. So basically a number that has a dot in it or a decimal point. So 9.0, that's a number that we call a float or double. So data type and float or double is something that we call the data type. So data type, remember a computer, right? It's not like us who can look at instructions like go make like I said, some people might read the recipe in a weird way. So you have to be very straightforward and explain step by step what to do. So that's why I'm saying a computer, the way it works, it's like a baby. I'll view a computer as like a baby because you need to be It can be powerful, but if you don't guide it the right way, it might end up touching a stove that's hot and end up burning itself. So it's like a baby. It's very intelligent, but without the right guidance, it might go into the wrong path. So you need to be very explicit. Remember us in our maths class, right? In our math class, you'd write something like x is equals to 9, right? Something like that. Of course, in programming, it's a bit different, but what this means, oh, so that means if I have something like y is equals to x squared, right? This means 9 squared, right? I think it's gonna be 81. Yeah, I think it's gonna be 81. So oh, x, it means it's a label for 9. So whenever I see x, I must replace that label with a 9. And so that means if I say y is equals to x squared, that means I'm saying 9 squared, which is 81. With the computer, it's very tricky. You need to tell it this x variable, what type of values can it store? That's where the data type comes in place. What type of data? Data means values, like 9. 9 is data. 2 is data. 81 is data. 9 squared, that's what we call data. If you look at 9, what type of data is it? It's an integer, right? If you look at 9.8, right, it's a rational or irrational number, of which in computers they call it a floating point or a double. So you have to explicitly tell it that this is the type of data that it can store. This is what happens with variables. When you create a variable, right, you're telling it to allocate memory, right? Memory meaning space, right? For example, um, you when you go and buy a cold drink, right, and you are thirsty, and you want to drink it now, you can't go buy two liters of Coke and drink it all at once. I mean, some people, but I'm talking about normal people. You'd obviously buy like 350 milliliters or 500 milliliters or a liter at most if you want to drink now and finish it now. At most, a liter is something that would be reasonable, right? And then for people, for things like family gatherings, you buy 2 liters, right? So the fact that it's called 2 liter, what does it mean? It means it can occupy a maximum of 2 liters of liquid, right? It's the same thing with variables. There's a size, there's a maximum that it can store. So when you provide that information to the computer, it also helps the computer know, okay, how big should the container be? Do you want a 2 liter? Do you want a 1 liter? Do you want a 350 milliliters? How big do you want it to be? Do you want 1 kg, 2 kg, all those things? That's what the data type tells it. So with data types, right? Let's look at different data types, right? Let's make different examples. So int, double, um, string, char, etc. Right? We These are the few examples that I'm gonna use, and then we have float, and then what else can we have? Yeah, for now, let's work with these data types. When you see an integer, right, it means that it should allocate 4 bytes. It depends. I'm not gonna be. It's not. It doesn't mean that is always the case. It depends on the compiler. Remember, the compiler, the translator, the person who's gonna be our middleman translating, the Google Translate, that's gonna translate from C++ to our machine language. That thing, it depends on it gives different sizes for variable for data types. It depends. You'd have to check for each data type if you really want to be sure how many bytes. So what I'm gonna do, right? This is gonna be 4 bytes. And remember, I didn't talk about it, but let's just get into it. So remember these two values, 1 and 0, right? So these two values, we call them bits or binary digits, right? Binary meaning two, exactly 2 digits, right? So it's called bits or in full binary digits. Binary bi meaning two, right? Binary meaning two. So when you have a set of values, right? So 1 byte, for example, there's this thing called a byte, right? 1 byte is, they gave it a name. If you have 8 bits or 8 binary digits or 8 binary digits, basically meaning 8 ones and zeros. If you have 8 ones and zeros, a combination of those, that's equivalent to a one byte. So when we say that it's 4 bytes, what do we mean? We just mean the exact number. Remember, each byte is 8 bits, and here I have 4. So that means it's 4 times 8, right? Because for each byte, there's 8 binary digits. So here there's 32 binary digits that I can represent to store an integer. We will get into all the important details, just that there's a lot to learn, and the video is going to be pretty long. It might end up being a 5-hour video with me just explaining all the subtleties and all the little details. We'll explain that in another video. So we have 4 bytes for integer, and then float is also 4 bytes. But remember, float and double, they represent uh, they represent fractions, basically. If you see a double and a float, you're representing a fraction. But that fraction, it's fine. You can write it like this and all those stuff. But usually you write it in this form. Let's say 3.4, 5.6, and things like that. That's how you write it. So that's what it's gonna store 4 bytes, which is 32 binary digits. And then double, it's obviously called, now you're gonna understand why it's called double. Double, it's called double because it has double precision, or it has double accuracy than a float. It also represents the same numbers, any fractional number or any fractional number, it's gonna be represented by a double too. But then double is twice the size that you can represent for a float. So therefore, if 4 bytes are represented for a float, then for a double, it's going to be double. So it's going to be 8 bytes. So that's how it works. And then usually a char or a character, a char is a word, this was derived from the word character. Character meaning a letter. You can say character or letter or letters of the alphabet. All those letters, all those characters, like a question mark, like an equal sign, a minus, all of those, we call them characters. So we can store those characters or tell the computer we want to store only those values by putting this data type called char. Or some people are going to pronounce it car, but it's actually pronounced as char, but it means character. So this one usually stores 1 byte. 1 byte, meaning it's 8 binary digits. And then we have string. A string, it doesn't have a size, like it doesn't have an explicit size, it resizes this one. You can just say it resizes. It grows as you enter information, right? There's no fixed length. It's gonna keep growing. That's a string. But a string just means it's a string of characters. If you remember those name bracelets that you guys like to buy for each other as couple goals, those type of vibes. You what are they called? Name bracelets, right? Uh, so the name bracelets, if you look at them, let me see. I want the right, yeah. So if you look at this name bracelet, right? Uh, nope. So if you look at this name bracelet, right? This is a name bracelet. If you look at this name bracelet, all of the characters, you see A, R, M, A, N, D, we'll call them characters or letters, right? Character is just another term for letters. D is the letter or a character. N is a letter or a character. A is a letter or a character. M is a letter or a character. R is a letter or a character. A is a letter or a character. So when you have a string of characters, we now call that it. When you have a collection or a string of characters, just call that a string, which makes sense because if you look at this name bracelet, where are you putting the characters? We are putting the characters inside of what? A string, right? There's that string that you get, and then you start choosing the characters or the letters. You put those characters or letters into the string, right? And then it forms that name. It forms your name, right? So it's the same concept in C++. They took it from that, a string of characters. So we have a bit of an explanation of data types. So let's start storing data types. How would you declare a data type, right? Let me close many of these tabs. I'm probably going to use the internet again, so let me just leave that open. So how would you declare data type, right? To declare data type, a okay, not data type. To declare, in order to work with variables, right? How do you declare a variable? To declare, it means to make it available. Available. To make it available, to declare. So how do you make that variable available to your application so that you can use it? So you do this, you say data type followed by a space and then followed by the name of a variable and then followed by a semicolon. The semicolon, what it does, it's a terminating character. It means it's like a full stop in English. Remember when the developers were sitting down and making these conclusions, they were taking some of the features from English and some of the features from the language that the computer speaks. So whenever you say a semicolon, it means end there. That's a full stop. So that's how you declare a variable. You say data type and name of variable. So let's declare data type, for example. So you say int a or x, semicolon. And then to initialize the value, you say the name of variable is equals to value and then semicolon. So for example, to say if I want to put a value into x, I say x is equals to 100. So let's see what happens behind the scenes when you create variables. So when you say int x, what does it mean? It means go into my computer, right? No, I want to open this. Go into my computer, create a box, some sort of a box and then give it a size of 4 bytes. 4 bytes, let's just say for the sake of simplicity, let's say 4 bytes is like 1 liter, and make this box or make this container be big enough to store something that up to 1 liter, right? And then give it a label or give it a name. So this variable is going to have a label. Let me put the label underneath it. It's going to be called X. That's the name of the variable. And then the name of the container, right? After I've made the container, what this does, right? Remember the equal sign, like I said, it doesn't necessarily mean the same. It's almost the same thing as in math, but your maths class, your maths is a bit different compared to computers. So what happens is the thing on the, okay, you can call this a value or expression. So in this case, the expression on the right hand side is just a value, which is 100. So when I see 100 there, what it does, it means take whatever expression or value on the right hand side and then put it into a container with that label. So it's gonna go there and say, oh, where's the label named X? Oh, there's X. Put the value 100. So it's gonna come here and then inside the box or that container, it puts the value 100. So every time you see a variable, this is what's going on behind the scenes. It creates a box or a container and then gives it a label. The name of the variable, in our case, the name of the variable is X. So X is gonna go to that, create a container and then name it, give it a label of which is X, and then store that value 100. So we now know how to declare variables, right? And initialize values. So I'm going to start declaring the variables in our practical, the way they wanted you to declare them. So from January to December, you need to create the integer variables, right? Integer variables, they mean it's a variable, the data type needs to be of type int. And remember, int is an abbreviation of integer. int comes from the word integer. So they basically want us to make ints. And there's a trick that I'm going to teach you to declare variables of the same type, multiple variables of the same type. So let's say x, y, z are integers. You can say int, you can do this. You can say int x, comma y, comma z. And remember, I said to initialize a value like this, you can say variable is equals to value or expression. Or you can combine into one thing. You can declare and initialize in one line. So what this line does, it means create a container of that can store integers, and it must be 4 bytes big. Basically, let's say for example, it must store a maximum of 1 liter, and give it a label or a name, X, right? So that label or name, imagine the Coca-Cola box, right? The Coca-Cola bottle. So let me show you what I mean by label name. Another example. So look at the Coca-Cola bottle, right? This is why is this thing okay? If you look at the Coca-Cola bottle here, you see the label, this red thing. We can imagine, you can sort of like imagine that like that's the label, right? Yeah, it is the label because if without it, you wouldn't know it's Coca-Cola. So it's the same thing with the variables. You wouldn't know that. You wouldn't know what that thing is without putting it, giving a label. So it allocates, for example, 2 liters, and then it gives it a label. It's Coca-Cola. That's the label. In our example, we have this container, sort of like a box or whatever you want to think about it, however you want to think about it. And remember the data type, it also tells us what type of data enters this box. For example, you don't buy you don't take your you don't when you're let's say you're moving out, right? You don't take your microwave or fridge and you put it inside a pencil case. That's not the right container for that type of data, right? For that type of thing, right? So the same thing applies with data types. Data types, it means what type of data can this thing store? And if you said integers, numbers like this, and you try, let me show you what's going to happen. You try and say dot 100 like this, it's going to complain. If I, let me build and run. If I run this, okay, let me remove that. If I run this, right, it should complain. It didn't complain, but it should complain. But let's make it a bit harder. Let's make it a bit more for straightforward. Try to put a string, right? And I told it that this box can only store integers. Let's try and do that. Now it decides to complain. So you see, conversion from const char what. You see, it's telling you that you've tried to converting. It's tried to store the thing that didn't belong to that box. The string is of type string, right? It's a string. It's letters, and this box that you made or this container can only store numbers, which is integers. So yeah, it raised that error. Oh, I remember why it's doing this. And there's also, let me teach you different ways. So there's also different ways of assigning values or putting values in a variable. Remember, this way you can just say is equals to 100, right? The other way you can just say x and then you put curly braces like this and say 100. You can do that. So now you'll be asking yourself, what's the point? Why should I choose? Why this? Why not that the normal way? This way, right? It's good because it gives you an error if before it gives you a clear error. So it checks whatever you're passing here, and then before it stores it into that label, it checks if it's the right type, and then it gives you an error. So if I run this, you see, remember previously it wasn't complaining. Now it complains before I even move on. It says, wait, this is a double. It means it's an irrational or rational value, and it's a decimal, and you're trying to store it in something that stores integers. So it's asking you, are you sure of what you're doing? So That's why most of the time in my code, I usually use the syntax because it helps me avoid this issue of having to initialize to get compile time errors, to get errors when I try to initialize that variable with the incompatible data. So if you look at this one, right? Let me put back the .9. You see the problem with the equals, right? It's gonna process it and it might crash, but it allows you to process. It doesn't give you the warning, doesn't do anything. And then with this syntax, it warns you, says, are you sure of what you're doing? Because that's a double. It's not an integer, and I'm expecting an int or an integer. So yeah, those are just few examples. So let's get to the program. I think I've explained a lot. So let's declare the variables, right? And remember with variables, when you're declaring variables, you need to use nope, wrong application. You need to use what you call, there's rules, right? So there's rules for naming variables. So rules for naming variables, number one, you must use lower case characters, right? Lowercase or uppercase, let me not, or upper case characters. Number two, variables cannot start with a digit or a number. And then number three, variables cannot be reserved words. Reserved words meaning the words already have other meaning. It has another meaning. So for example, int double, you can't do that. There's already another meaning for that word. You can use that. And number four, variables can contain underscores. So variables can contain underscores. So these are some of the rules that you're gonna follow, right? So for example, good variables would be um, int let's say num1, right? Or let me just not put the data types. Let's just say num1. Num1, you see, it has all the uppercase and lowercase characters. It doesn't start with a digit, and it doesn't have a reserved word. And it can also have underscores. So I can have num1 like this. You see, these are valid variables. Bad variables, right? It's something like this. Let's say, for example, you start with and say hi. That's not it. You say it. They say it cannot start with it. There's no character here. The only character that's allowed is an underscore. You can't be putting a $sign or what. Yeah, you can't be putting all those things. It can. Let me just say, it must start with, yeah, it must start with uppercase, lowercase, or underscores. It needs to start with one of these three things: lowercase, uppercase, and underscores. It can only start with one of those three things. If you look at this one, it started with N, which is a lowercase letter or character. But this one starts with the $sign, which is incorrect. So this is a bad variable. Or a variable, you say 1, 2. This is gonna give you issues because it starts with the 1. And we can test it out in our program, right? Simple. Let's say 1, 2. I'm creating a variable, right? Let's run. Exactly. It's gonna give you an error. So there's rules for these things. All of these rules that I wrote there make sense. And you see, that's the problem with C++. It gives you a weird error message. So just be careful with the way you're naming your variables. Don't start with the digit. It only starts with the lowercase or uppercase letter, alphabet letter. And or an underscore, and it can contain a number. That's it. That's all you have to know. So now that we know the rules, we can start naming our variables. So let's create our variables. Okay, the time is moving, so let me do this thing a bit fast. So the variables, right, the way I'm gonna name them, I'm gonna name them the exact same way, the way they are, January, February, March. So from January up until December, so that, and use names that make sense. Don't say J. Like, what do you mean by J? You see, what do you mean by J? J is very confusing. So that's why I'm saying always use variables that make sense. Use proper names. So I'm gonna say January like this, and then remember you could declare multiple like that, right? So I'm gonna declare them like that too. So I'm gonna say January, February, March, and then April. Yeah, and then here I'm gonna have May, June, July, August, and then here I'm gonna have um Sep July, August, September, October, November, December. So these are all my variables, right? But I'm noticing something that's gonna be that's gonna be problematic, right? The values that I'm gonna be storing are big. It's very big values, it's millions, right? So I'm gonna sort of like have few variables per line. So I'm just gonna write, let's just use two variables at most. So January, February, March, April, and then int May, June, and then int July, August, and then int September, October, and then int November, December. So we have all of the months. So let's initialize them to their values, right? So I'm just going to use that other syntax that you guys know is equals to. That other one, you can also use it. It's still fine. But for now, I'm just going to use this one. So equals to, equals to, equals to, equals to, equals to, equals to. So I'm going to write it like that. And then let's see our values. January is 83 million, right? And remember, million consists of six zeros, right? A pair of six digits, right? Zeros. So I'm gonna say 83, 1, 2, 3, 1, 2, 3, right? So another important useful feature of C++ is that you can add separators. Remember that in maths, right? You'd say comma and then you say comma. But you can't say comma like this because remember the comma already means something else in C++. It means it's going to take this as, oh, 83, three zeros and three zeros separate. So we can't use commas. So what we can do is we can use apostrophes like this. You can put an apostrophe at the top there, and then now you see it's easier to read. I see it's 83 million. So I'm gonna write it in that way. So 83 million, February is 12, March is 33. So 12, 1, 2, 3, 1, 2, 3, and then 33.49. Okay, let me just do this. 33.49, just to make things a bit faster. 76.52. 76.52, and then 58.14. 58.14, and then 29.91. 2991, and then 5, and then 100, and then 100. Okay, so there we go. I'm gonna have 3 digits here, 3 digits again. Okay, just for the sake of making this faster, I'm just gonna copy. Just gonna copy, paste, because they're all in millions, right? Paste, 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 paste. So to check if your program is still fine, to check the syntax and everything, you click the build button. Build, it means it compiles, it translates it. So if there was an issue with translation, let's say, for example, the syntax. Syntax, it means the rules of the language. For example, I forgot a semicolon there. If I say build, when it tried to compile and translate it to machine language, if it sees that you didn't follow the syntax rules, it's gonna moan at you and be like, okay, why didn't you, what did you do there? You see? But then usually it moans in the next line. It says, line what it's always confusing. So if you look at these errors, right? Okay, this one is a bit, it's close to what, yeah, it's actually what's expected. It says expected a comma or a semicolon before int. So before this integer, which is that line over there, it expected a semicolon or a comma. So before this integer on line 39, which is here, it expected a semicolon or a comma. And then I build it again. If it sees that you followed all the language rules and everything, the punctuation, you put a comma where you're supposed to put a comma, you put a full stop where you're supposed to put a full stop. In our case, it's not a full stop, it's a semicolon. If you followed everything and you did everything right, then it's not gonna moan at you, it's gonna compile successfully. So now we need to do calculations, right? And let me teach you, show you an example of few operators that we're gonna use. So we're gonna use the set of operators, right? When you see a star or an asterisk like this means multiplication. And then you see this sign, it means division. It means we are dividing. And it has this everything that you've been taught in maths it's applicable here. Everything you're taught in your math class is applicable here. Board mass, if you remember board mass, it's also applicable here. The zero division, you cannot divide the number by zero. It's also applicable here. Everything you're taught in your math class, it's applicable here. So and then addition is this, which is the same symbol as in your math class. And then minus just means subtraction. So we're gonna use a set of operators, right? So let's go back here and check. The name of each month must be stored as a constant string variable. Oh, each month. Okay, yeah, I see. So they want you to store. As people are asking a lot, the name of each month must be stored as a constant string. Okay, so let's talk about constants. You know constants, right? So the way I'm going to declare my constants, right? I'm going to declare them here at the top. I'm going to declare them here. So constants, right? Constant is a constant. When you say something is constant, um, if you for those who did physics and you know what constant means, it means it is not changing. It's constant. It's not changing, right? So we have the same principle in programming. But remember, programming it originated from mathematicians. So if you think you're gonna write code without knowing maths, I'm afraid you're in the wrong faculty. There's a lot of maths involved here. As you can see, there's multiplication, addition, subtraction, all those things. constants are also here. Everything, it was made by mathematicians. So we have constant, yes, it is not changing. And constants, for example, could be pi, right? Or Euler's constant, I think it's called Euler's constant, E. If you remember with your logarithmic classes, you'd say log of base E and what. Yeah, so just like the constants that we already have, so they are asking you to declare constants in C++. So you can declare constants like this, right? You use the keyword const, and then followed by the data type, and followed by the value. That's how you can declare a constant, and then a semicolon there. So this is how you can declare a constant, right? So data types we did, these are all the data types. But they want you to declare data type, or they want you to store the name as a string, the string variable, right? The names for the months, right? So I'm gonna go back here, and in order to use a string, right, we need to use another preprocess. We need to include it. It's not part of C++. It doesn't come packaged with C++. It was made by programmers, the string data type. So if you check the string data type, you should see, yeah, you don't see much there. There's a lot of header files included. You have to keep going down yeah, it becomes very confusing. There's a lot of files in there. So we don't have to worry about that, but just know if you want to make use of a string, you have to include it. It's not part of the language, just like this data types. And you see they're highlighted in blue because they come pre-packaged with C++. It is the default C++ data type. It's the data types that come as by default with C++. So the data type that they want us to use here is string, right? So we have to use string. And then the value could be an integer, could be what, but still, since we're dealing with string, we need to use double quotes like this. Oh, it's not complete. My bad. This is not complete. It's data type, and then you need to have the constant name here. So that's the syntax. So I'm gonna use the keyword const, and then the data type is a string because they want us to make string constants. And then constant name. The names of, remember the variables, our variables, we're using lower cases, right? And underscores and all that. They still apply, but the only difference with constants is that you need to write them, all of them in uppercase. You don't use lowercase. There's all of them, all of the individual letters or characters, and they need to be in uppercase. It's not a rule. It's just how C++ programmers concluded that they should write constants. It's not like the compiler is going to complain or anything, but it helps with your program to make it simpler. Okay, I forgot to say equals to there. So let's say January, right? I'm just going to call it Jan, and then I say is equals to January, like this, right? And then let's build and see if we are following the right syntax. And indeed we are. So we need to create a pair of constants, right? And there's 12 months in a year. So we need to have 12 of these. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to have Feb here, and then the value is going to be February. And then we're going to have March, MAR, which is March. And then we're going to have April. I'm just going to call it APRL, APR. And then this is going to be April. And then this is going to be April, May. So it's going to be May. And then June. Just want to say JUN, which is June, July, June, and then July. August, AUG, August, and then September, it's SEP, and then September, and then October, OCT, which is October, and then November, NOV, November, and then December, DCE, December. So we have our constants. So what happens with the constant? Remember the keyword constant means it's constant. You can't change it. Remember with the variables, right? Variables, they can be changed. That's why it's called variables. They vary. Vary meaning they change. So variables, they vary, they can change. So I can't just declare it without the const there. Because if I just declare it without the const, it means that I can change that variable, right? But I don't want to change it. So I'm just going to put the default keyword const there and then create the constant to make it tells the compiler when it's translating. So when I click build here, it's going to translate and say, oh, okay, these are not supposed to change. These are just constants. Like pi and Euler's constant. Um, this is pi and Euler's constant. So those values shouldn't change, right? So we have our constants there. I don't know what they want you to do. So let's see. So like each revenue, okay. So rands can be converted to into dollars by multiplying by the conversion factor. Each month's revenue must be stored into, you may hard code values into the program. Okay, they want us to hard code the values. So hard code, what does hard code mean? It means you literally wrote the values like this. You're not asking someone to give you the values. You wrote the values into your application or into your program. So you remember the program, we talked about it, is a set of instructions that perform a specific task. And then the name of each constant should be stored as a constant string. We did that. And then each revenue, we need to calculate the revenue. You see, they talked about it in the beginning, there at the top. They said it displays the revenues, right? These are the revenues. So I need to convert the revenues to, or in millions of rands. Oh, they're already in rands. Okay. Are they in rands? Or I think they made a mistake. They're supposed to say in dollars because there's a question in the at the bottom that says convert. Oh, it is in rands. We are converting $2, not from dollars to rands. Yeah, my bad. So we have each months are stored in integers. We did store them. If you check the program, there they are. Our integers are here. And then we have calculate the average revenue for the C++ using a C++ expression and store the result into a double variable. So remember when you divide, right? We talked about these operators, right? So now they want us to divide, find the average. How do you find average? Average is the sum of all of these things divided by the number, by its number. How many things were there? So there's 12, there's 12 variables to represent the 12 months of the year. So there's 12, I need to add up all the 12 values and then divide them by 12. And then they said, remember that when you divide, right? Whenever you divide, you say 1/2, right? Usually this would be 0.5. The problem with C++, right, and a lot of languages, when you just use the divide operator on two integers, right, on two integer values, it doesn't convert it to a double. It doesn't write it in this form. It just truncates. Truncates, it means that it just gets rid of any decimal points and then just takes the value in the front. So the answer would be 0 in C++. So to show you this, let me just output. So C out 1 divided by 2. You'd expect this to be 0.5, right? But it's not going to be 0.5, it'll be 0. As you can see there, it won't be 0.5. But if you want it to be 0.5, you have to say 1 divided by 2.0, which would be 0.5. So in order for you to get it in the double form, you need to have one of the operands, right? Remember there's these values, right? These characters, right? The star, the division symbol, the forward slash, which represents division, the plus and the minus for subtraction. They are called operators, right? So an operator, it does an operation on values. The left value, we call that the values themselves, they're called operands, right? So values are called operands, right? So operands basically meaning the things that are being operated on. You can imagine the doctor is doing an operation, right? So we would call the doctor, the person who does the operation, an operator. And then the thing that you're doing the operation on, or that person, that patient, the patient would call the person an operand, because he's operating on that person or on that thing, right? So in this case, 1 is an operand, 2.0 is an operand. That's the terminology for it. And then the symbol in between the operator is the operator, just the operator. And then this whole expression, we call that the operation. So what is this whole operation? It's a division operation. For example, the doctor is doing a heart operation or a lung operation. So similar to that. So if you want to get a double, or you want to get it in decimal form where it's something point something or something dot something, you'd have to convert one of the values or one of the arguments to a double. So let's remember we're expecting it to be a double, right? So double, and then I think it's they want us to calculate an average, right? So average. So I'm gonna give my variable a meaningful name. I'll call it average. Average, and then add up everything. So January plus February plus March plus okay, I'm just gonna write it to the over the next. I'm just gonna continue on to the next line. Plus April plus May, April, May, June plus June, July plus August, June, July, August, September, October plus October plus what is this? October, November plus November plus December. And then divided by the number of things that I'm adding. How many things am I adding? How many months? I'm adding 12 months. And okay, you shouldn't, okay, for the sake of making this program make sense, right? Don't just be throwing values in there like this one, 12. We call that a magic number, because the programmer's gonna look at it and like, okay, what does this person mean by 12? But okay, in this scenario, we are allowed to get away with it because he sees the number of months. It's like, oh, okay, the number of months divided by 12, okay, makes sense. But let's let's make it a bit easier. Let's also create a constant for the number of months. So constant, and then number of months is 12. And then instead of using that magic number there, let me use a variable called months. So now the user is going to see and be like, oh, those are the number of months. Now I see. The person is going to read your code. So remember BODMAS, right? There's BODMAS, brackets of division, multiplication, addition, and subtraction. So division, multiplication, they come before addition and subtraction. What am I doing here? I'm adding. So that means it's going to divide first. See, that's the problem now. It's going to say December divided by a number of months, which is going to give me a very incorrect value. So I need to find a way to make sure that it adds first. How do I do that? You use brackets. If you remember in your maths class, if you wanted to emphasize that you should start with this, you always start with what's in the brackets. So I'm going to put the brackets there and then the number of months. But remember, we need to convert this to a double, or one of the results to a double. So to convert to any type, right? Casting, right? There's two ways you can cast. So to cast or converting from one data type to another, you can do it in two ways. First way, you use the name of the data type, and then you put brackets, and then you pass within this round brackets whatever variable or value you want to cast. So for example, I can say I want to cast to an int. I'll say int, open brackets like this, and then I want to cast 23.4 to an int. So this would be an example of how you do that. Then the second way, which is the safer way, this is the most safest way of casting. You say static underscore const less than symbol, and then the data type name here, and then round brackets, and then here you put in the value, or it can be a value or an expression. Just remember, it can be a value or an expression or variable. It can be one of these three things. So for example, to cast to an integer, I would say static underscore const, and then put the int because I want to cast it to an int. And then I would say 23.4. So casting means converting. I'm converting this argument or whatever is passed inside the round brackets to this type that's inside the less than and greater than symbol. So that's how I'm going to use the second way, which is the static const approach, because it's safer. It's the safest way to cast. So you can either cast one of the values, right? Remember if you look at our output, let's do it again. To see out, if I say 1/2, right? That's just gonna give me an integer. It won't output it in the form that I want. So to output in the form that I want, I have to convert one of the values to a double. So it's either the first argument and it gives me 0.5, or I only convert the second argument. Remember, 2.0 and 2 is the exact same thing. Yeah. So 1 divided by 2.0 is giving me a double, or converting both to a double. You can do that. It's still gonna give you the same thing. In my case, there's many ways I can go about it. I can convert the sum that I'm gonna get here. I can convert that sum. But let's make it simpler, right? Let's not write it in like this. Let's just create a variable for the sum, int sum, and then store everything here so that to make our code readable. So I'm gonna have sum here and then plus this, and then I'm gonna add the other months. And then add this. So there it is. I just rewritten it in a nicer way. So now I'm just gonna say sum divided by months. So let's build and see if the syntax is still fine. Yeah, we are following the right syntax rules. We are doing the right thing. So sum divided by months, number of months. So now we can either cast this one or both. It's up to you. So I'm just gonna cast the sum. After getting the sum, I'm just gonna cast it. So static underscore cast to a double, so that I can get the answer in the form of a double. So I'm just gonna cast it like that, and then I'm done calculating the average. So I'm done calculating the average, and then it says create a const to store the conversion factor. So the conversion factor is this value 0.053. So they want you to create a constant for that. You see, its constants are good because you don't want having to have magic numbers in your code. So const double, it's a double. It's conversion factor. Okay, for double, you don't use const. You're gonna use something special. You see it, it's gonna complain. 0.053. I'm expecting it to complain. Okay, it didn't complain. Okay, that's fine. Okay, that's fine. We're not gonna get to. I'm not gonna talk about what I was expecting, and it's gonna take time. Probably gonna spend like 20 minutes trying to explain that. So, okay, this time around, const is working. Is not complaining. So let's continue going down. So we have this. We have the conversion factor. We have created a constant for it, and then it says compute the average revenue. Um, convert the average revenue from rands to dollars, right? So, okay, let me write it, use the right name, average revenue, like that. And then let me say double average revenue in dollars, right? Yeah, it's a long variable name. I don't advise you to write such long variable names, but I'm just writing it for emphasis so that you can understand the differences. So how do we convert? Remember they said you just multiply the average, multiply the average rands in the average revenue in rands times the conversion factor. And we made a constant for that variable, conversion factor. And remember, we talked about multiplication. Use the star symbol to multiply. So double is going to take the value. So this is an expression on the right hand side, right? It's going to say go to this box with that name average revenue in rands and take that value and return it, and then multiply that value with whatever value is stored inside this container, which is called conversion factor. And then that result that you get from multiplying, create and allocate memory for a double, which is 8 bytes, in a box, and then give that box a label average revenue in dollars, and then store the result that's gonna be returned on the from the right. Oh, that's gonna be returned by the right hand side, and then store it inside this variable or that box with that label. So yeah, it's gonna be like this. And then I think we're already done, almost done. So output the monthly revenue table in a user-friendly way, right? Okay, so they want us to output the user revenue in a friendly way. So yeah, it becomes very tricky now. So I'm just going to show you in a simple way. We'll talk about manipulators in the next class, but I'm just going to show you in a simple way. So basically, they want you to display all of the month and its value like that. So let's do that. So display the name of the month and its revenue. So you see the importance of comments, right? You see, it explains what I'm about to do or what the following code does, or what the following set of statements does. So I'm gonna output, so see out. Let's do it one at a time. So we have January, right? No, it's Jan. Yeah, the constant is Jan. And then, okay, so I'm gonna do this Jan, then on a new line. Yeah, I'm gonna say Jan and then on a new line. Okay, let's talk a bit about what's going on here. When I say Jan, right, look at the important part about the direction. You need to look at the direction of the operators. When you're using cout, you're outputting to the console. What is the console? When you run your program, is this black thing? This is the console here. This is the console. So when you output, what's going to happen? This is what happens when you output. So there is this thing called a buffer, right? So you get your value from, okay, this is another person, right? This is a user. He types in something and then it goes into there. So, but for now we're just looking at output. So how does output work? So this is how it works. So I said, if you look at my code, I said gen, right? Gen, remember when you use a variable like this, it means go to that box with that label and take what's inside the box. If you scroll up, what's inside the box for gen is this string January. So what's going to happen, right? This is what's going to happen. Uh, this string of values January is going to be passed into this buffer or this terminal. This is the terminal, right? Let's just say terminal for now. We'll get to the input. So this string, I'm sending it to this side. Look at the direction. It's going to this thing, right? If you look at my code, nope. If you look at my code, look at the arrows. In which direction? I'm going to the left hand side. It means go to this thing, which is the output device. The output device now it's by default it's gonna be the terminal or the console. So what this means, it says send this thing, and this is the direction. Send it into inside of this thing, which means send it to that black thing that you're seeing on the screen. So this is how it's gonna send it. It's gonna send one character at a time. It's gonna send J, and then send A, and then send A like that, and then send N one at a time until it eventually becomes January. So that's why you see January on the screen. So if I run this, you see January, right? So what does NL line mean? It means end line. So it means whatever you start displaying, don't display on the same line. When you display from the next line. That's what ENDL means. So let's keep doing that. I'm just explaining it in the most basic manner. So we have that, right? We're sending to the terminal. I also need to send the constant, right? Or the value in millions. So I'm going to say January like this. And then here I'm going to put an end line like that. It should output the way I'm expecting it to output. Exactly like this. So how did it get to that point? So it sent, okay, I need to close this. It sent January, right? That text, that string. And then I said the next the next output that you're gonna be getting, start it on a new line. That's what that keyword end line means. So what's this new input, which is that integer? So that's why when you see here, if you look at it, it started it on the next line. It didn't go to the same line here because there's that end line character. So I'm gonna use this to my advantage to keep displaying the values. So before I display each integer, right, or each value, I'm just going to display the names, right? So let's make it, let me add a tab there and then send February in there and then send, what is this tab? It should be, I should put two tabs, but I'll see. Let's see what we have so far. Okay, it's just mar, MAR. Tab. Let me see. Why is it so? Okay, that's a bit better. Yeah, it's a bit better like that. So it's gonna be like that. I'm gonna have February and then that, and then another tab, and then April, and then another tab, April, May. What did I call it? It is May. I don't know why it's not highlighting, but yeah. And then another tab, May, June, and then another tab, July, and then another tab, June, July, August, and then another tab, September, and then another tab, October, and then another tab. Come on. October, November, and another tab, December. And then I should put an end of line character to tell it to start on a new line. I'm not sure if is it visible. Okay. Okay, there's something that I need to fix here. You see the values, right? It makes the terminal become so long. So I'm gonna shorten the values in like the constants themselves. I won't write the month, the name of the months in full. I just say Jan, Feb, March, MAR, and then April. Okay, I'm just gonna write it in capital letters like that. And then April, May, June, July, August, September, October, November, and December. Then let's run it again. Yeah, that's a bit bad. So you see now, the values, the strings are appearing, they're enough on the terminal. So those two tabs, now they're making my output look bad. Yeah, you see now it's fine. So let's see now. Let's try to output the values, right? So for the values, I'm pretty much gonna do the same thing. Yeah, I'm pretty much gonna do the same thing. Like that. And then instead of the characters, I'm outputting the actual values. Instead of the strings, I'm outputting the actual numbers, the numbers in millions. And then April, May, June, July, August, September, October, November, December. So we have all of these values, right? Let's see. Yeah, for the values, right? The tabs are a bit, yeah, it becomes very hard to output it in a table format. So you have to be very careful the way you're outputting. So let's look at the values. Let's try to just use spaces instead of tabs. Let's see how many spaces we need. And then for the tabs, we'll see if we need to add more tabs for our strings. Okay, let's see now. Yeah, pretty much. Yeah, pretty much. It's pretty close to what we expecting. That's better now, right? So now we just need to improve our program, right? Its readability. So let's try adding 2 tabs at a time and see if that's gonna suffice. Not good. It's not gonna work. I was just testing the few. So I need to keep shifting the values there. Okay, February is in the right place. So March, let me see. After March, right? Yeah, just before March, I need to add an extra space there. Perfect. And then just before April, I need to add an extra space there. And then add another extra space. Yeah, April is fine. And then just before May, add more spaces. And then June, just before June, add also spaces. Yeah, we're just gonna work with spaces now because if I use tabs, yeah, this is the most simplistic way of doing it. Okay, June. I think June is fine, right? Yeah, June is now fine. July. July, I, I overdid it. Still way too much. Okay, that's fine. September. Okay, so I just need to work on October. So before October, they just add those extra spaces there. Okay. Uh, okay, October is fine. November. There's November and then December. Perfect. So there we go. We have our program, our application. It's outputting the way we wanted it to output, right? The way they wanted us to output. You could sort of like make it a table format, right? You could. So like a table format in the sense that there is lines and stuff. So let's make it a bit beautiful, right? So let's say C out and make it look like it's a table. Give the impression that it's like a table, right? So I'm gonna put this equal signs there just before I output. And then let's try again. There we go. So we have our output there, and then we put it after here too. We have our output there. And then you also put it afterwards here. Should look prettier now. Yeah, so you see we have January, February, March. Yeah, it looks prettier now. So there's our application. So now we need to calculate and display other information, right? Yeah, this tutorial is becoming too long now, but it's fine. So output the following information below in the table. Okay, so let's average revenue in rands, right? So I need to output the string itself, average revenue in rands, and then send the average revenue in rands to my output, and then send an end of line character to say that it should start on a new line. And then average revenue in dollars. And then it's going to be average revenue in dollars and line. I think I should use, okay, that's fine. And then we can close it off by making it beautiful at the end. And then there we go. There's our program. It's beautiful. There's our output. Yeah, you see, it does take a bit of a lot of effort to output things in a nice way in C++, but we'll see that you can avoid having to repeat yourself like this, like having to write as a long cout statement like that. Okay, but it's still fine. It's still fine. I feel like it's still fine. So there we go.